Welcome students. So today we learn concrete mix design. Okay. Generally students are asking me to explain mix design calculations. So today I'll explain mix design by IS method. If you are following this method, it will be far easier to understand this mix design. So now we take an example illustrating the mix proportion for concrete M20. Step 1. We follow steps because it will be easier to remember and understand. So first come first step is design stipulations. First is characteristic compressive strength. At 28 days on field is 20 Newton per millimeter square. Tolerance we consider 1.65. Generally we take 1.65 1 in 20, right? And standard deviation, so let's consider 4 as per IS 456/2000. So now we firstly learn some important terms like what is target average compressive strength, that is F bar CK or F dash CK, that is target average compressive strength at 28 days, and FCK is characteristic compressive strength at 28 days. Okay. Now you know the difference in between target average compressive strength and characteristic strength, right? So the word shows that characteristic strength, it should be like 20, in our case it is 20 Newton per millimeter square, right? And we get the target average compressive strength with the help of formula that is given in IS 456, right? So I'll give you all the explanation with page number, close number, maximum support I'll provide you to design the mix, make a mix design of particular grade, right? So S is say standard deviation. So what is deviation? First of all, the word deviation is difference between fixed value and observed value, right? So whatever the fixed value is, and we should consider the observed value. Suppose if you are getting more than 20 Newton per millimeter square or lower than 20 Newton per millimeter square. So the next one is T. T is equal to a statistical value depending upon the accepted proportion of low results and number of tests, right? So now we consider our case. So now I tell you and explain you why we have taken tolerance T 1.65, because the result of testing of cube, it should not go lower than the result actual, that is 20 Newton per millimeter square. Means when we are going to test compressive strength of molded cubes, right? So it should not be less than 20 Newton per millimeter square. Okay. If we have casted 20 cubes, okay, and in that 20 cubes, only one cube shows the compressive strength less than 20 Newton per millimeter square, right? Means 5% of result is going down. Okay, so this is the meaning of tolerance T, right? Now standard deviation. So in our case we have considered grade M20. So it shows for as per IS 456 2000, close number is 9.2.4 and table 8, right? So I have given everything, like close is given, table number is given, right? It will be easier for you to find out from IS 456. Now IS 456 is very much important. I tell you, it's very important to study because it's important for design of structure too. So it gives useful information. It is full of information actually. So one should go through IS 456 2000. Now the next is degree of quality control. That is very good. Mode of placing, manual or pump, you considered. Workability of concrete, that is 0.90. Compacting factor, right? And type of exposure we consider severe, right? And now we switch to step 2, raw material testing data, right? So we have completed design stipulation, that is first step, and now we switch to step 2, raw material testing data. Step 2, raw material testing data. First, cement OPC 53 conforming IS 12269 1987 and specific gravity of cement, that is 3.15. Third is bulk density of cement, that we will consider later. Fourth is aggregates. In that we consider fine aggregate is sand, fine sand. We have considered fine sand as fine aggregate. That's conforming to zone 1 and its fineness modulus is, we have considered, we have taken as per the data 3.82, right? So in coarse aggregate we have parted CA1 and CA2, right? So first you can pause this video and write down the data peacefully. Okay, so first come first is specific gravity of fine aggregate, that is 2.7, coarse aggregate CA1 2.76 and CA2, that is 2.78, and bulk density of fine sand is 1.7, CA1 is 1.43 and CA2 is 1.52, right? Then water absorption, fine sand 0%, coarse aggregate CA1 1.60%, CA2 1.30%. Free surface moisture 0.90 of fine sand and CA1 0, CA2 0. Okay, and fineness modulus, 3.82 of fine aggregate. So now as per step 3, determination of design or target strength, that is F-CK, and the formula given in IS 456 is FCK plus T into S. Now we know the values and its meaning we have already discussed, so we don't waste time. FCK we have taken 20 Newton per millimeter square, T is equal to 1.65 and S is equal to 4, that is standard deviation. F-CK we get 26.6 Newton per millimeter square, or we can say MPa, megapascal. Now step 4 is selection of water cement ratio, right? So we consider 2-3 values for that, that is from table 9, page number 23, we get 0.60 water cement ratio. And second is from table 5 of IS 456, maximum water cement ratio is 0.55 for mild exposure, and minimum cement content, that is 300, right? So now in this case we have considered as per experience water cement ratio 0.56, or in some cases we can consider minimum of above. Now you can see table number 5 given in IS 456. We've considered exposure mild, right, and reinforced concrete. I can show you like 300, okay, and the maximum free water cement ratio, that is 0.55 for grade M20, okay. Now you can see table number 9 of IS 456, second option to consider water cement ratio, proportion for nominal mixed concrete, right? So in this case we have considered M20, and in that case 30 by 50, that is 0.6, okay. So in second case, as per second case, water cement ratio is 0.6.